risaga is the name used in Minorca for a curious oceanographic phenomenon that occurs in some coves and ports, both in the Balearic Islands and in other seas on the planet. It consists of significant variations in the sea level, with periods of oscillation several minutes long. Here, we refer only to the case of the Balearics, and specifically to what happens in the port of Ciutadella in the northwesternmost point of the island of Minorca. In Ciutadella, sea level oscillations may have an amplitude of half to 1 meter in cases that we would call ordinary, or up to 2 meters in extraordinary events. The port of Minorca has a normal oscillation period of 10 minutes. This means that there is only 5 minutes between minimum and maximum oscillation, so the currents that form may be even more spectacular than the change in level itself. In the most intense cases, shallower areas of the port may be drained of water in just a few minutes, possibly leaving boats stranded. Minutes later, the water returns, climbing rapidly with great force, creating an intense current. This may cause moorings to break and boats to be dragged around, bumping into each other or against the jetties. In some extreme cases, as occurred in 1984 and 2006, many boats were sunk or completely destroyed. Jetties were also flooded with serious damage to parked vehicles and port premises. But how does this risaga originate? And what causes the phenomenon? Phase 1. Atmospheric disturbance and the oceanic response. In a specific, fairly well-defined synoptic meteorological situation, internal atmospheric waves are generated, generally moving from southeast to northwest at a speed that may reach around 100 kilometers an hour. Some of these waves can give rise to convective storm systems, and there may be violent discharges from the upper atmosphere. At surface level, all this causes rapid and rhythmic oscillations in atmospheric pressure, accompanied or sometimes replaced by isolated pressure jumps. Such oscillations or pressure jumps may reach the order of several hectopascals or millibars, causing a response on the free surface of the oceans in the form of long waves, of several centimeters in amplitude. In the open sea, in deep waters, long ocean waves are propagated at some 600 kilometers an hour, decoupled from the atmospheric forcing that creates them. Phase 2. Atmospheric oceanic coupling and amplification. When ocean waves reach the Minorca Channel, which is approximately 80 meters deep, they slow to approximately 100 kilometers an hour, and this may cause coupling with the atmospheric disturbance, wave or pressure jump. As long as this coupling lasts, there is an efficient energy transfer, and ocean waves are rapidly amplified, reaching some tens of centimeters in amplitude. Phase 3. Coupling in Ciutadella port. Due to the peculiarly long and narrow layout of the port of Ciutadella, incoming ocean waves with periods of the same order of magnitude and comparable may be amplified by resonance, causing the waves to be amplified up to 10-fold or more, even on occasion reaching 4 meters in amplitude. In almost all Meteo tsunamis, including both more intense and ordinary events, there is usually one major oscillation, causing the port to drain and fill up, followed or preceded by a series of secondary oscillations of lower amplitude, which may last for several hours.